been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for 7.4, special right triangles. We're going to look at two types of special right triangles. The first one is a 45, 45, 90 degree triangle. So these are still right triangles, but the other angles are kind of special in that in this example, you have two congruent angles, which means you have an isosceles triangle. So let me show you how this works. So this is a square ABCD, and I've drawn the diagonal so that now I have two congruent right triangles. So I'm going to go ahead and say that the side of the square is 1. So that means that this is also 1. So how would we find DB? Well, we would use Pythagorean theorem. 1 squared plus 1 squared equals x squared. 1 squared is 1. 1 plus 1 is 2. So 2 equals x squared. To get x by itself, I'm going to take the square root of both sides. So x is the square root of 2. All right? So in a 45, 45, 90 degree triangle, the ratio is always going to be 1 to 1 to square root of 2. Again, if it's a 45, 45, 90, that means these angles are congruent, which is why these sides are congruent. And the hypotenuse will always be the square root of 2 times whatever the leg is. So here the leg is 1, therefore the hypotenuse is 1 times the square root of 2, which is the square root of 2. So let's look at a problem to see how this works. So here in example A, I obviously have a 45, 45, 90. Why? Because I know the angles add up to 180, so this must be 45 degrees. I know that the leg is 8. Therefore, I know that the other leg is also going to be 8, and the hypotenuse is going to be 8 times the square root of 2. It's as simple as that. There's nothing you can simplify there, so that would be your answer. Over here, I know the legs are 3 square root of 2, and because those are shown to be congruent, I know that these angles are congruent, which means they're both 45 because this is already 90. So what is the hypotenuse? The hypotenuse is going to be 3 square root of 2 times the square root of 2, which is 3 times the square root of 4, and the square root of 4 is 2, which is 3 times 2. Therefore, it is 6. So the hypotenuse here is 6. 3 times the square root of 2 times the square root of 2 is going to give you 6. Example C, I know the hypotenuse, and I know these angles are congruent, so I know it's a 45, 45, 90, and I need to find out what x is. So if in order to get from the leg to the hypotenuse, I multiply by square root of 6. In order to get from the leg to the hypotenuse, I multiply by square root of 2. So in order to get from the hypotenuse to the leg, I need to divide by the square root of 2. The problem with this answer is that we cannot leave our answer with a radical in the denominator. Okay, that's kind of faux pas in math. We don't do that. So we do what's called rationalizing it, which means I'm going to multiply by 1, but I'm going to multiply by 1 in the form of square root of 2 over square root of 2. That is, does equal 1. But what happens is now I have 8 square root of 2 on the top, but what's square root of 2 times square root of 2? Square root of 4, which is just 2, right? Square root of 2 squared is 2. Now I can simplify the 8 over 2 to be 4, so my answer would be 4 square root of 2. X is 4 square root of 2, which is both legs. So that's how you get from hypotenuse to leg. Now we're going to look at the 30, 60, 90 triangle theorem. So this is also a special right triangle, but this time we have a 30, 60, 90, not 45, 45, 90. So you'll notice here that because these two angles are different measures, the legs are also different measures. So we'll call this A and this B and this C. C is always the hypotenuse. So A is the shorter leg. So we're going to call A X. Okay, the A leg is going to be X. That's the shorter leg. It's also the leg across from the 30-degree angle. That's the smallest angle. So if A is X, then B is going to be X times the square root of 3. And C is going to be 2 times X. So I'm going to draw this another way here for you. So if this is my 30-degree angle, this is x square root of 3, and this is 2x. Okay, and so it's going to be very helpful for you to draw this anytime you're working with a 30, 60, 90-degree triangle, because then you can just use proportions to solve the problem, because any 30, 60, 90-degree triangle is going to be similar. So let's look at example A. So I know that this side is 9, and that's the side opposite the 60-degree angle, okay? So I'm going to set up a proportion here, okay? And I want to make sure that I set it up correctly. I want to solve for one variable at a time. So I'm not going to worry about the y right now. I'm just going to worry about the x. So this x on this triangle corresponds to this x on that triangle. So x over x equals, and then I need to use the 9, so 9 over, and then 9 corresponds with the side across from the 60-degree angle, which is this guy. So that's going to be over x square root of 3. All right, so this is going to be a little bit tricky here, but we're going to get through it. So I have 9x equals x times x square root of 3. Okay, so 9x equals x squared square root of 3. Well, do you notice I have x's on both sides? So what I can do is I can actually divide by x here. X divided by x is 1, so that leaves me with 9. X squared divided by x is going to be x. Okay, x squared over x is x, and then I still have the square root of 3. And so now, if I want to solve for x, I need to actually divide by the square root of 3. And remember, this is the problem we had earlier, is we need to rationalize this. So in order to rationalize 9 over the square root of 3, we're going to multiply by the square root of 3 over the square root of 3, which is going to be 9 square root of 3 over 3, because square root of 3 times square root of 3 is square root of 9, which is 3. 9 divided by 3 is 3, so the answer is 3 square root of 3. So that is what this x is here, 3 square root of 3. So now we need to solve for y. Y is the hypotenuse, which is going to be 2 times whatever the side opposite the 30-degree angle is. The side opposite the 30-degree angle is x, which is 3 square root of 3. So y is going to equal 2 times 3 square root of 3, which is 6 square root of 3. So just to clarify here, x equals 3 square root of 3, and y equals 6 square root of 3. So we used a proportion to solve this. All right, looking at our next problem, we know that the side opposite the 30-degree angle is the square root of 3, and we're trying to find the longer leg, which is going to be x times the square root of 3. Well, what is x? This is x. So x here is going to equal square root of 3 times the square root of 3, which is the square root of 9, which is just 3. So that would be 3. And remember, just for practice, the hypotenuse is 2 times x. And again, if this is x, then this is going to be 2 square root of 3.
I've been waiting way too long.